All right, let's dive in. Picture this. You're the senior architect on call. It's a totally normal Tuesday, until it's not. We're going to walk through a real-world incident and see how having the right kind of telemetry on Google Kubernetes Engine, or GKE, can take what feels like an all-night disaster and turn it into a 10-minute fix. And there it is, the alert that makes your heart skip a beat. PagerDuty starts screaming, 503 service unavailable errors, and the reports are coming in specifically from your users in Europe. The clock? It has officially started ticking.
You know, every SRE, every platform engineer, they know this feeling in their bones. Suddenly, management is pinging you for updates. Customers are lighting up social media. And you're right at the beginning, staring at a blank screen.
So what's the first question that pops into your head? It's always the big three, right? Is it the app? Did we push some bad code? Is it the network? Is something broken somewhere? Or is it a dependency? Is something we rely on failing us? Without the right tools, you're honestly just guessing. Okay, so what's the usual playbook here? You start tailing logs from a dozen different services, you're frantically clicking through dashboards looking for CPU spikes, you're trying to line up timelines, it's this chaotic search for a needle in a massive, massive haystack.
And here's the absolute crux of the problem. If you don't have a service mesh watching the traffic between your services, you have these huge blind spots. You might see that a service is unhealthy, sure, but you have no clue why or who else it's impacting. You're basically flying blind.
But here's the thing. We're not in the dark today. We've got a service mesh on GKE, and that gives us this incredible toolkit. Think of it like a digital detective kit. We've got a live map of all our services, we've got super detailed metrics for every single API call, and we have traces that can follow a request from the very beginning to the very end. So, let's put these tools to work.
And this is where we shift from panic to process. We're not guessing anymore, we are following the data. The telemetry from the service mesh is going to act like a set of breadcrumbs, leading us straight to the source of the problem.
You always start at the highest level. Before you dive into a single log file or check on a pod, you need that 30,000-foot view. What does the health of our entire system look like right this second? And boom, right away, this just shows you the power of the mesh. Instantly, the service graph lights up with red. The front end looks good, the API gateway is green, but the checkout service, it is clearly failing. In literally seconds, we've narrowed our search from our entire system down to one single microservice. Okay, but we're not done yet. We've found the problem area, but how deep does it go? Is the entire service on fire, or is it something way more specific? You know, if it's just one API endpoint, our fix can be a lot more targeted. We need to zoom in.
So this is the next layer of our investigation. We know that checkout service is the culprit. The next question is, how is it failing? So we're going to double-click, zoom in, and ask the mesh to break down the error rates for every single one of its API routes.
And there it is, clear as day. Looking at the cart, totally fine. Adding something to the cart, no problem. But trying to process a payment at cart/process payment, a whopping 98% error rate. We've just gone from a failing service to a single specific failing function call. That's progress. Okay, so we've definitely found the what. We know what's breaking, but that's not the root cause, is it? We still need to know the where and the why. Why is it failing? Is it a bug in our code? Or is it having trouble talking to something else? For that, we need to trace a single failed request through its entire journey. And this trace, well, it tells the whole story. The request comes in, hits our checkout service, which then makes two different calls. The call to our own database, super fast, perfectly healthy. But that call to the external payment gateway, that's where everything just falls apart. It's timing out after 2.5 seconds and throwing that 503 error right back at us. And just like that, all the different pieces of the puzzle just click into place. The service graph got us to the right service, the per route metrics pointed to the exact API call, and now this distributed trace has shown us the smoking gun, the downstream dependency that's actually failing.
Now, for the final piece, we take this new information and we correlate it with our existing cloud monitoring data. Remember how the original alert was about Europe? Well, look at this. We filter our dashboards by region, and it could not be more obvious. The checkout service running in the US is happy as can be, but the one over in EU West 1, it's a total disaster. And that latency, 2,500 milliseconds plus, it perfectly matches the timeout we saw in the trace.
So there you have it. We have our root cause with confidence.
It's not our code, it's not our internal network, it's a regional problem with that external payment gateway, and it's only affecting our service instances running in Europe.
Okay, let's hit pause on the incident for a second and take a step back. What did we just learn here? And more importantly, why is this a huge deal for pretty much any team running on Kubernetes?
This, right here, is the key takeaway. Without a service mesh, this kind of investigation could have easily burned hours, pulling in half a dozen engineers into a war room. With the mesh, a single person just followed the data trail and found the root cause in less time than it takes to brew a pot of coffee. That's a game changer.
So, what should you be asking for? No demanding from your platform. This right here. This is what I call the minimal telemetry baseline. You need a real-time service graph to see your topology. You need the golden signals, latency, traffic, errors for every service. You need per route metrics to isolate problems, and you absolutely 100% need distributed tracing.
Ultimately, what this is all about is a fundamental shift in how you work. You stop being a digital firefighter, constantly putting out fires and reacting to alarms. Instead, you become an engineer who genuinely understands the complex dance happening between all your services, and you can start fixing problems before they become full-blown outages.
So I'm going to leave you with this one question to think about. Think about your last major incident. You probably found the what and the where eventually. But how long did it take? How many people did it take? And how much faster could you solve that exact same problem next time if you had these tools?